Hello, dear students. Let's see this question 3.14 of Irodov. The question states a very long straight uniformly charged thread carries a charge lambda per unit length. Find the magnitude and direction of the electric field strength at a point which is at a distance y from the thread and lies on the perpendicular passing through one of the thread ends. So here is a diagram of the question. This is a infinite wire. Charge per unit length is lambda, and at one end, this is one end. At a distance y from here and perpendicular to the wire, we have to find electric field in magnitude and direction. So this is what we call the semi-infinite uniformly charged wire. So let me take an element of the wire. This element is, say, at a distance z from this end, and the element that I am taking, this element is of length dz. And this element, the element that I've taken, subtends angle d theta at this point. And angular position is of this point is theta. Theta, whereas we take all the element from this end to that end, theta will go from 0 to 90. And through this element, will cover the whole wire. So you can see that clearly that this z is equal to y tan theta. And this distance of this point from here is, say, r, and r is y sec theta. This is r. So number one, z is equal to y tan theta. I'll be needing dz. So dz is equal to y sec square theta d theta, and r is equal to y sec theta. So that is one thing. And now the charge on this little element, suppose the charge on this element is dq. So dq is obviously lambda dz, and dz I've just got above. Now electric field, because of this element dq at the required point, is obviously radially away, and this is a dE vector. And now I can write the magnitude of d vector would be the k times of the charge dq, and that dq is lambda dz. Divide by distance square, which is r square. R is a y sec theta, so y square sec square theta. Putting the value of dz, will get k lambda y sec square theta d theta, and divided by y square sec square theta. So this term gets cancelled. So magnitude of electric field in d, that we will get k lambda by y d theta. And now this electric field will have some x component and some y component. X component means the component perpendicular to the wire, and the y component means the component parallel to the wire. So this is a dex, let me write, and this is dey. So if this angle is theta, so this angle is theta. So dex is equal to de cos theta. And see, this thing is a constant. And dey is the de sine theta. So that will be k lambda by y cos theta d theta. And we have to integrate it from 0 to pi by 2. If I integrate it from 0 to pi by 2, so I will get ex. So ex will be integration of dex, and that will be integration of d cos theta, and this will be integration of this whole thing from 0 to pi by 2. And this integration is 1. So what we'll get? We'll get k lambda by y. And similarly here also, this de sine theta will be k lambda by y sine theta d theta. So Ey would be integration of this thing, that would be integration of this thing, and that would be integration of this thing, obviously from 0 to pi by 2. And this integration is from 0 to pi by 2 is 1. So we'll get this k lambda by y. So Ex and Ey are both equal to k lambda by pi, and k is obviously 1 upon 4 pi epsilon naught. So overall magnitude of electric field, E is obviously the square root of Ex square plus Ey square, and that will get root 2 k lambda by y, and this electric field would be, because both x and y component are equal, so that would be like this, making angle 45 degree from the x-axis and away from the wire. So I can say towards the making equal angle from the y-axis. That is the direction, and magnitude we have already calculated. Thank you.